The next 5 questions, we were supposed to solve each equation by factoring, and I wanted you to write your final answer in a solution set notation. Or the emphasis on these is trying to get you to factor. There are maybe other ways of doing some of these, but the primary thing I want to do is to have you demonstrate your factoring techniques to me. So in this equation, 3x squared minus 75 equals 0, it's exactly the way we'd like to see it. It's basically in standard form. Our factoring techniques, the first thing we always look for is the greatest common factor. After that, if we don't have a greatest common factor, then we can go and then test to see if it's a difference of 2 perfect squares. So is it the difference of 2 perfect squares or 2 squares? If not, is it a trinomial? And if it's a trinomial, then it has to factor into 2 binomials. So if it's trinomial, then it factors into 2 binomials. That's kind of our general strategies that we've been using throughout the year. So the first thing I'm going to check on this one is there a monomial factor in each of those? And there is. We can factor out a 3. 3 goes into 3 once. So I got an x squared, and 3 goes into 75 25 times, equals 0. So we just did our greatest common factor. Now I want to check my result and see if it's the difference of 2 perfect squares. Well, I got a perfect square, and there's a difference, so it's definitely a difference of 2 perfect squares. So now we're going to factor it again. The difference of 2 perfect squares factors into 2 binomials that are almost identical. It's just that the sign between them is different. So the factors of x squared are x times x. The signs have to be different because this is negative, so it's plus and minus. Factors of 25 that will give you a 0 is a negative 5 and a positive 5. So once we get this completely factored, then we use the idea, it's called the zero factor principle or theorem. It's a relatively simple idea. It says if I have 2 numbers and I multiply them together and their answer is 0, then I know either A is equal to 0 or B is equal to 0. So what we do is we break these 2 ideas, these 2 factors up, and find out what they have to be. And this principle can be applied into bigger and bigger concepts or more and more factors, because now I got 3 numbers that are multiplied together that equal 0. So now I know either the A is equal to 0 or the B is equal to 0 or the C is equal to 0. So the whole idea behind factoring is to get it so that I've got numbers that are being multiplied together that are equal to 0, which forces one of these numbers to be 0. Well, the 3 can't be 0, but I sure could put in a value of x that would make this factor equal 0. I'm going to find out what that is. And I could also find a variable answer or a number I could replace x with to find an answer of 0 as well. So then I solve each of these independently. So if I were to subtract 5, I'd have x as a negative 5. And certainly we should be able to see that if I put in a negative 5 in for that x, a negative 5 plus 5 gives me a 0, and a 0 times any of these other 2 numbers is 0. Then similarly, if we take this one and solve it, we're going to add 5 to both sides. So I have 2 solutions here. One is a negative 5, and the other is a positive 5. So that's our solution set for number 3.